So welcome for those of us who are joining on YouTube. So we're going to post these videos to our YouTube playlist. Now, people that are here right now, did you go online and were you able to check the YouTube playlist and see that there's the recordings up there? Yeah, thumbs up. Excellent, excellent. So far, so good. Yeah. So if you ever miss one of these, if you can't make it, so what we'll do is we'll keep trying to post these online, same playlist, same location. All right, so last time we covered product rule, we were thinking about, so I still have some of our notes, right? So we went through an example of product rule where if I have the product of two functions, we look at this rule right here where both functions come into play. We talked about thinking of that as a framework, right? So we have four pieces that go into it. And what we're going to do today is we're going to use the product rule, which I have up here conveniently, to think about the derivative of a quotient. So if you have two functions that are being divided like this, right? So you have a numerator and a denominator. How can we take the derivative of something that looks like this? And the trick to this is to rewrite it as a product. Okay, so what we're going to do is I'm going to take this and I'm going to multiply both sides of this function by g of x. Okay, so on the left side and on the right side of this, I'm going to multiply by g of x. And what I end up with is I get something that looks like this. G of x times q of x equals f of x. And so when I look at this, so on the left-hand side, I have a product, right? So when I look over here, I have a product, and when I look over here, this is just a regular function. So if I think about this and I want to take the derivative, I can take the derivative of both sides of this equation, and the right side is going to be fine, right? The derivative of a function is just f prime, but over here I've got a product. And so what I'm going to do is use product rule to take the derivative of both sides of this. Okay, so on the right-hand side, what we're going to end up with is we're going to end up with just f prime of x. And then on the left-hand side, we're going to have to use product rule. So we're going to do this framework where we see something that looks like this. Right, so we're gonna look at this. This is g of x, q of x, and we're gonna use this formula right here. So when we go through product rule, the first thing we do is we say, okay, I'm gonna take my first function g of x, and then I multiply by the derivative of my second function, so that's q prime of x, and then I do it in the other order, right? So then we're gonna have a g prime of x, and then we're gonna have our q of x. Okay, so when I look at this and I break it down, this is just in complete generality for any function. And really what I'm wanting to do is I want to figure out, hey, what is the derivative of q prime, which I have right here. Okay, so this is my function q of x, and it's a product of something. And I want to figure out, hey, how do I get this thing by itself? Right, so I really want to know q prime of x is equal to something. And so when I set this equation up, what I'm going to try to do is just get q prime all by itself. Okay, so we'll move this up a little bit. And what I can do is I can subtract this part over to the other side. And what I'll be left with is I have this g of x times q prime of x is equal to f prime of x minus g prime of x times q of x. Okay, so I have something that looks like this. And again, my goal is to get q prime by itself, so I'm going to divide both sides by g of x, and I'm left with this. Q prime of x is the derivative of f minus the derivative of g times q of x, all divided by g of x. Okay. And to take this one step further, we're going to keep going here. And I know from the beginning that q of x has this form f of x over g of x. So what I'm left with is f prime of x minus g prime of x times a quotient all over g of x. Okay, so when we're thinking about a quotient rule, we have this sort of crazy formula that appears on the right-hand side. And what you're seeing right now is really a mess. Okay, so I want to just pause here and see if everybody is following along. So we're doing this in complete generality. And we started back at the beginning, right? So if I rescale this, we started way back at the beginning with a function that is a quotient. And then we took a derivative, we used product rule, and then the rest of this was algebra, right? So we subtracted this over to the other side, we divided by g of x, and then we just replaced q of x with its original definition up at the front. Okay. And what we can do now is I really want to simplify this. And through a quick algebra trick here, what we're going to do is we're going to multiply the numerator and denominator by g of x. Okay, so when I multiply the numerator by g of x, I'm going to have to multiply everything. So I'm going to have to distribute through that by g of x. And what we're left with is, right, so we're going to take g of x, we multiply it by f prime. So you get this g of x, f prime of x. And then when I take this g of x and I multiply it into this, what we're going to see is this g of x and this g of x are going to end up canceling. So we have minus, so I'm going to write it, let me write it in a certain way. Minus f of x, g prime of x. And then in my denominator, I'm going to get g of x times itself, which is really g of x squared. Okay? And so this is the form of our quotient rule. Okay, so just like we had before, we had this definition for a product rule. How do I take the derivative of a product of two functions? This, what we just walked through, is the derivation of how do we get the derivative of the quotient of two functions. Okay, so you'll notice that we have, it looks similar to product rule in the numerator, except we have this subtraction sign. And then we have our denominator, which ends up being squared. Okay, so in the product rule, we had 4 parts, and in this quotient rule, we're going to actually have 5 parts. Now, often what we do is we use this a mnemonic. And if you think about a quotient as, right, so as a quotient is this f of x over g of x. Sometimes what I like to think about this is high, right? So this is like the numerator, it's high, and then the denominator is low. So if you use these words, low and high, you get this funny sounding thing where you would say it's low d high, which is low d high, right? So low, the denominator times the derivative of the top, minus, and if we keep going, this is high. Oops. Right, so this is high, and then we have d low, and then this is over low squared. So without lie, I've been teaching calculus for a while. I took calculus a long time ago. I still say this to myself pretty much every single time I take the derivative of a quotient. I say low d high minus high d low over low squared. Okay, so as I'm going through, I really don't memorize this formula. I have this sort of mnemonic in my mind, low d high minus high d low over low squared. I learned it a long time ago and I still use it. It's sort of it's got a like a rhyme to it to me. Low D high minus high D low over low squared. And it's just an easy way for me to remember what's going on. Of course, in your case, I don't require you to memorize anything, so you'll be able to use your notes and you'll have this formula available to you. So if you want to use it, if you're comfortable just using the formula, but it helps me to think about it this way instead of looking it up each time. Okay, so let's go ahead and let's try out an example. Right, I have on this next slide. So we have a quotient, and I have two functions, right? So my numerator is x to the 5th power, and my denominator is cosine of x. So as I'm going through and I think about this, what I do is I think about it as a framework again, right? So there's going to be 5 pieces. It's going to look something like this, and my job is to go ahead and fill in the spots, right? So if we think about it, can we remember what goes in each spot? So we said it was low, right? So low D high minus high, and then this would be technical difficulties with our board here. So this would be high D low, and then we would down here, we'd have low squared, right? So to put this all in place, what we would want to know is we just need to know where to put each of the pieces. So we need our denominator, right? So we need our denominator, which is going to be low, right? So we're going to get cosine x times the derivative of our numerator. Okay, so when I come over here in my second piece, I have d high. So the derivative of our numerator, we're going to use power rule for that one, right? So this is 5x to the 4th. So low d high minus, right, high, we just leave that alone. And then we're going to multiply by d low. So derivative of cosine is negative sine x. And then all that's divided by low squared, so I don't have to change cosine x at all. I just do this and square it. Okay, so I'm going to pause here and see if we've got any questions. You can type them into chat. You can shout them out. Let's take a moment just to see what's going on here. We're good. Thumbs up, thumbs down, thumbs up, thumbs up. So you can, yeah, we're good, we're good. Things are good. All right, lots of thumbs up. Okay, so let's drop the Blackboard here, and then we're gonna go back into our book. So is everybody aware how to get to the book? All right, so the webpage is activecalculus.org. And so if you're not here, right, so in your browser, it's also linked on our Plato page, but if you type in activecalculus.org/single, it will bring you right to the home page, and then we're down here in section product and quotient rules 2.3. Okay. And so what we'll see is what we just walked through as this derivation. So if you want to see it in the book, but also here's our, right, so here's our quotient rule and an example. So what I want to do is take some time to think about these examples right here. So we have activity 2.3.3, right? So we'll try out A, B, C, and D. And I want to give you all an opportunity to think through these and see if you can work through them and what kind of questions you have. So we are going to go into breakout rooms here. So do you remember we did breakout rooms before? So what we'll do is there'll be 4 people. Let's see, 4, 4, and 3. So you're going to be grouped into 4, 4, and 3. And we'll take, so it's 9:35. So we'll take, say, like 10 minutes or so, 10, 13 minutes. So at 9:50, I'll try to bring us back together, and we'll see how we did on these 4. Okay, so I'll put you in groups so you can maybe chat with each other in a less intense setting. Okay, so in a second here, you should have an invitation to a breakout room. So go ahead and join those, and then talk to each other about the problems.
So I got confused and thought it was homework, so I did it.
Hello.
Hi.
All right, so a little less intense, right, with not everybody here. So any questions or things that I can clarify for you all?
Once we get to the end, do we have to like solve it algebraically, or can we just like leave it?
So you can just leave it like that. So that's going to be a fine formula. There's a couple of situations if you end up having to take a second derivative. So if you took the derivative again, it's often to your advantage to simplify. But if you're stopping there, if that's your ending point, then you can just leave it like that. And on web work too, that will help on web work. So you don't need to simplify. If you do that framework where you put parentheses in, then that will help you out on web work as well. So Bella, was it Bella that asked the question?
Yeah.
Yeah. Does that answer your questions?
It definitely does, because I didn't know what to do at the end. So
yeah, so where I stopped, you could definitely stop there. And so as long as you have the right products in there, you don't need to simplify for web work. It'll take your answer. All right, so are you all, so I want to show you all something. So is somebody on a laptop? Can you hit your share screen button down towards the bottom? So Amber, are you on? It seems like you might be on a laptop. So hit share screen and then click whiteboard when it comes up.
Oh, wait, I didn't mean to do that.
That's okay. So what we're doing is like we can see your window, but yeah, do the whiteboard. So now everybody else at the top of your screen, when you click view options, you can choose annotate, and then you can sort of write stuff together here, right? So this is me. Hi. Right, and so you can put, stickers or you can put stamps and stuff. So you have stamps, there's stars, stuff like this, and then you can write text. So when you're in a breakout room like this, you can all interact, right? So you can all interact together. So if you wanted sort of like a shared board space, you can try to make use of this. So see if you can make some sense out of those, however many you can get to. 3 questions there.
Are we doing 2.3.3?
Yes. Yeah,
okay.
That'll be the first quotable one. So, okay. So what I'm going to do, I'm going to jump to another breakout room here and see how everybody else is doing.
Okay.
Okay. All right. Try your best, and then we'll come back together here in a few more minutes. Hello.
Hello.
How's everybody doing?
Good.
You hanging in there?
Yeah.
Yeah.
All right. So, how are y'all talking about your work?
We were just gonna try to do it by ourselves and then kind of
come back
Regroup.
together.
Yeah.
So I'm gonna show you all a trick that when we're in small rooms like this that might work well. So Caleb, are you on a laptop? Molly, you on a laptop?
Yeah.
Okay, so down one of you at the bottom. So Molly, can you share your screen? Click share screen, and then when it pops up, choose whiteboard.
Yeah, we were trying this last time.
Yeah, and you did this last time?
Yeah, and you can annotate and then you can draw.
Yeah, and so if you want to work together, you can all try out. You can try this out, and then
It's hard to draw with this though.
it's a little hard to draw. Yeah, I agree.
Yeah.
It is not the best thing, but it's something. And so you can also you can also use text, right? So so if you wanted to type like this, right, you could do some. It's not the greatest math type, but you could do something like this too, right? To try and sort of get some stuff across. Yeah, see if this helps out, and then if you want to, you can exit your full screen and then see other stuff as well. So try it out, yeah, and see. You could try it out individually and then sort of see what's going on. But so far, so good. Things are
Yeah.
so far.
Mm-hmm.
All right. Any questions for me?
No.
All right. I'm gonna jump to another room, and then I'll bring us all back together here in a little bit.
Great.
Hello. How's everybody doing?
Pretty good.
Hanging in there?
Yes.
All right. So how are we? I'm interested to see how people are collaborating in the breakout room. So how are we sort of able to share our work and whatnot?
So we're kind of going at our own pace and just checking in with each other when we have questions.
Yeah. Okay. So did you all use the whiteboard feature last time?
No.
Yeah. So Luke, you're muted, but if you can hit your space bar. So Luke, are you on a laptop? It seems like. On the bottom of your screen, can you hit share screen and then choose whiteboard when it pops up? So if you want to, so Emily, Erica, you can click on annotate. So you do view options, and then we can all sort of write on this. I know it's kind of hard to write with like clicking like this. It's not like the greatest thing. But it's something, right? So if you wanted to try and, share your work, this is a way, yeah, right? So you could try to do something like this. And then you can also use text. So if you hit the text button, right, you could say like, hey, my answer looks something like, this minus this divided by this, something like that, right? And so you could then type in these spots, right, what your answers are. So a couple ways to share. I know sort of holding stuff up to the camera is not always the greatest thing. But, all right, so you're not going to be able to edit mine, but you could do your own text.
Cool.
I don't think you can edit mine. Yeah, so kind of one idea for checking in with each other. But do you all have any questions so far? Things are moving reasonably well.
Yeah, I think we're good.
Okay. All right. I'm gonna keep making the rounds.
Okay, thank you.
You are welcome.
Probably messed up somewhere.
All right. This looks awesome. I'm so excited to come in and see this on the whiteboard. Very cool. How are things going?
Okay.
All right. So we're thinking through the first problem?
Yeah.
Yep. So this is what you have here. Let me annotate and so I can put a bam. This looks good to me.
Okay.
All right. So low D high minus high D low over low squared. All right. So does this framework kind of work out for you? Putting the parentheses in and then sort of filling in the spots. That works out well.
Yeah.
That's how it worked for me last night.
Yeah. You were thinking through it last night.
Mm-hmm.
Excellent. All right. So this is good. Did you think about, have you started on part B yet?
No, we literally just finished that one.
All right. Excellent. So seems like things are going well, and yeah, keep going. This looks great. I'm super pleased to see all this stuff. So I'm gonna jump in with another group, see how they're doing.
Okay.
He's just. Oh.
Hello.
Hello.
I just visited you all just a minute
Yeah.
ago.
Yeah.
So things are still good?
Yes, we're trying to figure
Yeah.
out Sadie.
All right. I'm gonna jump in the other room.
Instead of sine of t or negative sine of t plus 2t, I put 2t minus sine of t. But same thing.
OCD.
All right. So I am checking stuff out here. So low D high minus high D low. So this looks good. This looks good to me.
That was for B. For the first one,
That was
for
B, right? Yeah. Yeah.
f of x equals x squared isn't anything. That was just random.
Yeah, that's okay. So these both look good to me. These two.
So for C, you would just find the derivative of that and then plug in 0 to the derivative.
Correct. Yeah. So that's going to give you the slope of the tangent line. Yep.
All right.
Things are going well so far.
Yep.
All right. Any questions?
Nope.
All right. Keep going. We'll probably come back here and I'll bring everybody back together in probably 3 or 4 minutes.
All right.
What did you just
So this is F. And then this is, that's not a G.
See, I'm bad with the derivatives. So, is the derivative of sine of t negative cosine t?
I think that's just cosine.
It's
T.
just cosine.
Yep.
Yes.
Okay.
But cosine, you're thinking like when you do cosine derivative, you'll get negative sine.
Okay.
So Amber, have you created a sheet like this or anything like I did for?
Yeah, it's in my notebook.
So it might be helpful to just like a sheet like this, write them all down in one spot or something, and then
Yeah.
you can use that as a reference.
Those videos last night helped too.
Good. The ones that are the video
On
playlist
like
that's posted.
the ones that you had us like the ones on the YouTube.
Yep. Cool. That's good to hear. All right. So everything that's on the screen right now looks great to me, and then you just kind of put everything in there in the right spots.
Mm-hmm.
All right. So far, so good here.
Mm-hmm.
All right, so probably in a couple more minutes here, maybe 2 or 3 minutes, we'll come back together. So get through this one and then try to think about part C as well, and then we'll come together and see if people have any questions.
Okay.
Okay. All right. So what will happen is you'll see like a warning that says breakout rooms will close in 60 seconds, and so when you see that, that'll be your notification to come back to the main session.
Okay.
Okay.
Yep.
Thank you, Luke. Thank you.
2 days in a row.
I know, man. It's the breakout rooms that get me because I'm muted when I come back. They get me. Thank you. Okay. So how did that feel for everybody? It seems like a lot of us, when we started getting comfortable with that shared whiteboard, it was okay. It's a little bit slower than it would be regular chalkboard, but that's okay. It's something. But as I was checking in with everybody, it seems like most of us got through A, B, and a lot of us did C. That's right. Yeah, we're there. A, B, C. Yeah, thumbs up. So, so any questions? Anybody wanna throw any questions out there for us?
Did you want us to like simplify them like for A and B? Did you want us to simplify or just leave them in the
No, you can just leave them like they are. That's good.
And that's how like WebWorks would take it as an answer too.
Yeah, so WebWork will accept it like that. So so what we can do, so would it be helpful to sort of see what it would look like on WebWork to do one of these?
Yeah.
Is that would be helpful for people? All right, so let me bring up WebWork and we can check that out. So I'm waiting for it to load up here. Okay, so homework 7. I'll find one that asks us to do this. Okay, so here's what I'm gonna do. I'm gonna share. I'll share for us, and we can look at a WOBWORK question. So we're able to see this reasonably well.
Yes.
Okay, so this is a product rule one, but if I were doing this on WebWork, so the way that I would approach this is I would do the same thing. I would look at it as a framework. So I know that the derivative is going to look something like this, right? It's going to be something times something plus something times something. So as I'm going through, what I would be doing, what I would want to put in these spots is I would say, hey, I have my first function here, right, which is t squared plus 4t plus 8. So I would put this here, t squared plus 4t plus 8. And then in the next spot, I know that I have to take the derivative, right, the derivative of my next function of first times the derivative of the second. So this one would be 14t. And then, right, then I have, in this, I would have to take the derivative of my first one, which would be 2t plus 4. And then over this one, I would just leave this, so 7t squared plus 4. Okay, so I'm not simplifying anything here. And so what I'm going to do is I'm going to go ahead and then preview. So I click this button a lot, and you can see that this is what WebWork is interpreting. So you have your first function times the derivative of the second plus the derivative of the first function times the second function. And so then we can go ahead and, right, we can check this, and it says it marked this one correct. Right, so I think yours probably says submit. So mine's a little bit different because it's the teacher view. But see how I didn't simplify this at all? Right, there's no simplification, and it still accepted our answer. So I think this helps. And if we jump over to homework 8, we can try to look for one that has a quotient rule, right? So this first one we have this. So when I think about quotient rule, I would actually do the same thing, right? So I'm going to have something like this in my numerator, and then all of this is going to be divided by something in the denominator. Now, the thing with WebWork is you're going to have to put your numerator in some sort of parentheses because you want the entire thing to be divided by this denominator. And so this just helps me make sure that I have everything in the right spot. And when I look at it now, I have this framework that's already mapped into WebWork, and then I just have to fill in the pieces. Okay, so I would type in something like this, and as I'm going along, I say to myself, hey, low d high, right? So low, this is just going to be 1 plus cosine x. And then d high, right? So the derivative of 5 sine x is going to be 5 cosine x, right? So low d high minus high. I'm just going to leave this alone, not going to change anything. And then the derivative of my denominator is going to be negative sine x. So the derivative of 1 becomes 0. Cosine becomes negative sine. And then I'm going to have my denominator, right, 1 plus cosine x. And then all of that I want to be squared. So without even checking or submitting anything, I can preview, and it will show me a typeset version of this that WebWork is considering. And so I double check here, right? Low d high minus high, and then d low over low squared. And we can go ahead and check. You can see no simplification. I left it pretty much the same as it was before. And then we've got, and I got this one correct. Okay, so oftentimes some of these derivatives can get pretty tricky in web work, but for me personally, I think this framework idea really helps out, right? It sort of sets the spot, so it helps you avoid things like, you know, negatives or missing parentheses if you sort of set them all in there at the start. So I don't remember whose question this was anymore, but does this help out with sort of how we would put these things into web work and what that would do? Yeah, so Erica, things are good. All right. All right, other questions? Throw them out there for me. We feel good about it? All right, so we've got about 6 minutes left. So what I want to do is see if we can keep going. So we can keep going in the book. And one of the next things that we're going to see is we see product rule, we see quotient rule, but sometimes what happens is these things get mixed together, and we're going to have to use them at the same time. Okay, so let me go ahead and bring up that Blackboard again, so we can use that. Okay, so what we just did is we worked through a lot of these in 2.3.3, and now in 2.3.4, we'll see that, hey, sometimes, right, so if I look right here, sometimes in one single problem, we're going to have a product rule and a quotient rule. Right, so I'm not going to do this same example because you can see this one worked out already in the book. And then in some other times, what we're going to find is, oh, hey, you're going to have a quotient rule, but inside of that, you have a product rule, right? So see how our numerator here is a product, but then it's inside of a quotient. So you're going to see stuff like this where you have a product rule inside of a quotient rule. So what I want to do is work through an example like this, because I think they can be a little bit tricky. And then you'll have some stuff to practice down here in 2.3.4. So let's go ahead and jump over to a Blackboard. I have a problem already up for us here. And so let's try to think through this one and decide sort of how we would attack it. So what rules do we think we're going to use here? Are we going to use product rule? Are we going to use quotient rule? We're going to use both. We're going to use both, right? A lot of people say both. So which one's first? Do you use product rule first, or use quotient rule first? Product rule first. Okay, so a lot of people are saying product. So you actually use quotient. You're going to use quotient rule first. Okay, so why is that? So the product, right? So what we have is the structure is we have a quotient, right? So this bar right here, that's our quotient, and the product is inside, right? So the product is inside of the quotient rule, right? So we have this quotient that is our larger structure, and the product happens in the numerator, right? So the product happens in the numerator of this quotient. Okay, so since the product rule is inside, right, it happens as our numerator, that's going to tell us we're going to use quotient rule first, right? So we have this up here, we have a product inside of the quotient. Right, so this function is inside, this product function is inside of the quotient. So our derivative, when we set it up, we're going to first use that framework for a quotient rule. So I'm going to make it reasonably big here. Okay, so I'm thinking ahead, and what I notice that I left a lot more space for this one right here, the derivative of our numerator, because I'm going to have to do a product rule inside of that. Okay, so as we're thinking through this, we go through and we say, hey, all right, so I'm going to think low, right? So low, D high, right? So D high is going to go here. I'm actually going to skip that one right now because that's going to take a little bit more time. We're going to have to use product rule. So low D high minus high is just going to stay the same. Then we have D low, right? So D low is the derivative of e to the x. And then we know the derivative of e to the x is just e to the x. Low D high minus high D low over low squared, well, that's just e to the x squared. Okay, so I'm like 90% of the way done here. And all I have to do is then execute the derivative of my numerator, which is a product rule. And so what we'll see here is we do our first function times the derivative of the second, right? Derivative of sine is negative cosine plus the derivative of our first function times our second function. Okay, so these things can get reasonably complicated. But there we have it. So is that readable in here, in this region? So Kaylin, is it like this all the time? Could we have a quotient inside of a product? Depending on how you think about it, yeah, you could have a quotient inside of a product. So, so let's give you an example of maybe what that would look like. So if I had a function that was like this, sine of x times, let's say 2 to the x over x, something like this. If you were thinking about it this way, then you could use a product rule first and then your quotient rule. Or you could rewrite this. You could rewrite this as 2 to the x times sine x over x. And so if you're thinking about it this way, you could use product rule first. If you think about it this way, you could use quotient rule first. So it's just a matter of making sure that you're picking the right functions in the right spots. Okay, so these, algebraically, these are the same. And then if you think about it this way, you do a product rule, and then you would do a quotient rule for this. Or if you thought about it this way, you could do quotient rule first, depending on which one's inside. Okay, so so let's go back. Did I make a mistake? Why is the derivative of sine negative cosine? Emma, yeah, you're absolutely right. That was my error. Thank you for catching that. So derivative of sine should just be cosine. Thank you very much. So my apologies for that one. Any other questions? So we're 2 minutes over our time here. So I don't want to hold you too long. But any other questions before we go? All right, so you should be in pretty good shape if you want to start really working on the web work. And for next time, what we'll do is, if you can, take some time over the next couple of days to think through this activity right here. Right, so these this activity 2.3.4. And then try to look at an example down here, this example 12. So if you could think through those, example 12, when we come back on Friday, I'll make a note that we'll take a bit of time to field any questions on that, and then we're going to move on to to derivatives of the other trigonometric functions. So we're going to move on to section 2.4. Okay. All right. So I hope everybody is doing well. But we'll call it here, and we'll see you all on Friday. You're welcome. Have a great one. Stay safe, everybody. I'll see y'all later.